Assalamualaikum warahmatullahi wabarakatuh. My name Syed Amiruddin Hilmi bin Syed Muhammad Al-Bakir, DE 180111. Our PBL Door Opening System. Introduction. When analyze interior this document, the term get to control system insinuate to an electronic card get to control system. The electronic card gets to control system business and an uncrypted get to card rather than a brace key to permit get into the secure zone. This day, the term get to control system most frequently insinuate to a computer-based electronic card get to control system. The reason of a get to control system is to supply quick accommodating get to those individuals who are authorized, while at the same time keep get to unique individual. For door opening control system, the DC engine have been utilized in this framework. The standard joke that leaf hooks a brace key may be thought of as fundamental shape of and get to control system. For literature review, the appearance for the most part incorporate a housing, a door giving access to the housing, a large system for retaining the door in a closed position and releasing the door to an open position, and interlock switch system. The door opening system further includes a door opening command interface for getting a door open command, and control hardware designed to initiate the motor of a door open command from the door opening command interface. The door opening system likewise includes a gear part configured to engage with the resilient part to cause the resilient part to arch the door from the closed position to the open position, and motor configured to drive a gear part. The door opening system involves a resilient part for unjacking the door from the closed position to the open position, wherein the resilient part is liberated from contact with the large system and the interlock switch system. Passive three-phase alternator substituting current into the starter winding of the engine produce a circular pivoting attractive field. Within the attractive field, the rotor winding cuts an attractive field to create an accurate current. The rotor winding within the closed way, moreover, produce an electromagnetic drive. DC engine with the highlight of wide extent to stepless speed control, solid overburden capacity, quick reaction speed, great solidness, ease of support, and so on, applies in the different area. The turning portion of the engine is known as the rotor, which is utilized to create magnetic torque and acceptance electronic constraints. The settler portion of the DC engine is known as the starter, and the most reason of the starter is to make attractive field. On the other hand, when K are increment, the offshoot gets to be little, and the speed of reaction gets to be slower. And when we experiment the extent of KD, the overshoot is apparently little with moderate rise time but settling time. When we increment the extent of KP, the increase overshoot of the framework increment and the consistent state below the diminishes.
I'm Fidas, and today I would like to explain about the problem elaboration. First of all, from the question, we must find the mathematical model derivation. From that, we can find the transfer function. After we find the transfer function, we must analyze the system, whether it's stable or not. There are two methods used to determine the system whether it's stable or not, which is Roth-Hurwitz and Ziegler-Nichols. For the Roth-Hurwitz, if all roots at the first column has the same sign, it means the system is stable. For example, for the first column, all the sign is positive, so the system is stable. The benefit of Roth-Hurwitz, We can determine the system whether it's stable or not without solving the equation. For the Ziegler-Nichols, there are three common parameters used, which is Ki, Kd, and Kp. Kp stands for controller path gain. Ki stands for controller integrator time constant. Kd, controller derivative time constant. Okay. For this question, firstly, we must do the manual and auto tuning in MATLAB software. Next, for the manual, the time is reset to its maximum value and direct to 0 and increase the gain until loop oscillate at a constant amplitude. However, for the auto tuning, it is very simple. We only choose the tuning parameter and it is based on control process. Lastly, we must, after we do both for the manuals and auto tuning, we must analyze the response from both tunings and manuals and compare it with the system without controller. Lastly, from this system, we must find all the variables such as rise time, peak time, and settling time, and so on. We can use PID control system. That's all. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Ahmad Zarkhwani bin Aziz. My metric number is DE180173. So, I will explain how we solve this problem in this project. First of all, we have to derive the mathematical model to identify the transfer function in this project. We also have to draw the block diagram. After we got the transfer function, we have to know the stability of the system by using Roth-Hurwitz stability criterion. After we know the stability of the system, we can proceed for the next step, which is we use Ziegler-Nichols tuning method in order to calculate the gain value that we will use soon in MATLAB. After that, we calculate for Ki, Kd, and Kp. Kp is to decrease the rise time, Kd to reduce overshoot and settling time, and Ki to eliminate the steady state error. After we calculate all of that, Kd, Kp, and Ki, we proceed for the MATLAB. First, for the PID type P, we run in MATLAB, we get the graph, and for manual, we got 885.619. For automatic, we get 8.3405. And for rise time, for manual, we got 0.194, and for automatic, we got 3.52 for rise time. And for the rest, we can see it in report. After that, we also have to find PI. We have to find PI. First, we use manual tuning by using Ziegler-Nichols method. We get the graph. After that, by auto tuning, we also get the flow of the graph, the shape of the graph. For manual, P, we got 797.0571. For automatic, we got 4.2057. And for I, we got 1186.27. And automatic, we got 0.19045. After that, we also have to find PD. we got the shape of the graph by auto-tuning also. And for P, we got manual P, we got 1416.99. For automatic P, we got 38.9684. And for D manual, we got 142.83. And for automatic D, we got 30.154. And lastly, for PID, we also get the graph, a very nice shape graph. For P manual, we got 1062.7428. For P automatic, 29.7862. And for I and D, for I, we got I manual 2635.77. For automatic I, 5.0824. For D manual, we got 107.12. And for D automatic, 34.8811. And the rise time for manual to automatic is increased. Manual is 0.147 and for automatic 0.982. So we got all of PID value. We got all the value for rise time for manual and automatic, for settling time also, for peak time, and reduce steady state error. Thank you.
As a conclusion, from this problem-based learning, we can learn PID controller in more details and specific. Next, we can know how to solve from mathematical derivation until transfer function. Third, we can analyze the system whether it's stable or not using Roth-Hurwitz or Ziegler-Nichols. Then we can also calculate manual tuning using Ziegler-Nichols tuning second method. Lastly, the most important thing, we can understood the relationship between Ki, Kp and Kd. That's all from me. Thank you.